Welcome to AppSec 101, a new series where we'll discuss the basics of application security, as well as industry trends and best practices. In today's episode, I sit down with Jimmy Rabin, a seasoned application security veteran with over 11 years in the industry. Jimmy will share with us the basics of static code analysis, the differences between static application security testing and dynamic application security testing, and he'll also touch on why static code analysis is so important for developers. So without further ado, let's dive in, and I hope you enjoy this episode. Maybe Jimmy, to start things off, we could just talk a little bit about your background and your experience with static code analysis and kind of how you got into it.
Yep. So my background is in information systems. I started my career in Java development and web application development specifically. After a number of years in development, I moved into application security as a result of a very improperly designed news search input box in a government application that returned 26,000 officer records and their social security numbers, which led to fraud, but also led to the government assigning $10 million to this problem and led to the hiring of Jimmy as a Fortify expert, right? So that's where I got my start in application security, was with the Air Force, specifically on a project to go around the Air Force scanning their code and auditing reports and presenting those findings to developers, teaching them how to use these tools continuously so they could make less mistakes in the applications that they were building for the Air Force. And so I started in professional services. I have a lot of experience building fairly complex, large enterprise application security programs, and I moved into product management about 2.5 years ago. All right, what is static analysis? Static analysis is determining in proprietary code if you have made application specific security mistakes or included vulnerabilities in proprietary code that you wrote. So developers' jobs is to write proprietary code to solve problems, and our goal is to, while they are building that application, to be able to fundamentally model their application. So no matter what languages are used, we are going to parse that into a common intermediary format. That gives me a means of which I can run rules and analyzers that simulate different attacks, right, in that proprietary model. So I've built a complete representation of your proprietary code that's typically generated as a part of the build, but it's about making static analysis efficient across languages, across different logics, business tier, database layer, presentation layer, right? We have to connect all those dots. Static analysis is about application security vulnerabilities specifically. And so it's one major part is the translation, or the aspect I mentioned of taking your proprietary code and turning that into our intermediate model, right? And that's, we parse your source files, put it into our common normalized syntax tree, and then we're able to run a multitude of analyzers like data flow, structural, semantic, configuration, buffer. These are different analyzers that are designed to find different types of vulnerabilities. And we have a software security research group that all they do is write new rules for these different analyzers. So they are going to discover new types of vulnerabilities, right? And they are implementing that in rules that we deliver 4 times a year. So static analysis is 2 parts: the translation that I mentioned, the analysis phase where the rules and the analyzers come into play, and then we display those results to you. Static analysis requires a detailed analysis trace of where individual, as we follow data through a complex system, we give you a map of that, right? So we're going to give you a specific node where we saw data come into the system, where we saw an assignment, where we saw that pass to an execution point in code, and that's all presented to you as far as the static analysis result. Static analysis is dealing with weaknesses, not vulnerabilities. So a vulnerability would be an open source component like struts, version 1.0 has a known vulnerability and it's published and everybody knows about it, and the fix is to upgrade that open source component. You are using a component that has a vulnerability. That's a vulnerability. It's an exploit. It's been documented. There's detailed reproduction steps. It's an exploit. We can find that same type of weakness, right? But it's not a vulnerability, because we are classifying it as a weakness because we're creating a representation of your application and then simulating that attack through our analyzers. But we're not actually having to exploit the system, and the system's not actually running. I've built a model of your proprietary code, and then I'm asking questions against that model with my rules and my analyzers. Every potential vulnerability that we find is a 0 day. Nobody knew about it before it existed. We built the concept of what cross-site scripting looks like or SQL injection looks like in rules, but they are simply weaknesses which require auditing, right? Require application knowledge, right? And require them to and require developers to look at these issues. These are issues meant for developers, right? If you do not understand the syntax of the language you are looking at, it will be very difficult for you to determine, without just completely relying on Fortify, whether we are correct or not, and whether you want to fix this or not, and how you want to fix this, right? We give you details, we give you general recommendations, right? But there's always application context that a developer can manage. For example, we know there's a web application firewall in front of this application. Therefore, we designed it a certain way, knowing that that's always going to be designed that way. Therefore, we're not going to fix certain classes of vulnerabilities because Fortify doesn't know about this application firewall. And so it's another layer of security that Fortify doesn't know about. That's context. The other concept I would mention with static analysis would be the concept of dependencies. So we've talked about you write your own proprietary code, I generate a representative of that model, and I can tell you what vulnerabilities you have, but you're also calling functions or methods from a dependency, which is distributed as a binary, and you're simply referencing that. That's code you didn't write, right? However, Fortify writes specific rules for specific open source components. We publish a third-party supported library document so that we can follow data flow between proprietary code and into a component that you did not write, right? So that we can understand how data flows into a component and out of that component in the context of finding application vulnerabilities. So we don't just have to know about your source code, we have to also understand exactly what libraries you are building your application on, because you're going to be referencing functions that we don't have a representative model for. You included that component as a compiled binary. You didn't give us the source code for it. You don't want to know about vulnerabilities in struts that only struts developers can fix. You want to know about vulnerabilities in your proprietary code. And you just want us to understand data flow into a third-party component and back out into proprietary code. And Fortify handles that for you as well. So that's kind of how static analysis works.
Yeah, thanks, Jimmy. That's some good information. Maybe could you also touch a little bit on the difference between Sas and Dast?
Yeah, so fundamentally, dynamic testing means the application is actually running. So if we were to give an example of a web application, the web application must be deployed. It must be on a web server. Web Inspect will throw a request at this web server and observe dynamically what the response code is, right? So dynamic results are much closer to actual vulnerabilities or exploits. They will have significantly fewer false positives, right? But they will have significantly more false negatives, meaning code that they're not able to test. They can only test what is dynamically presented to them. Dynamic testing is coming in like an attacker would through a web browser. Hence, they're going to have a lot less false positives, but if they can't find a link for something, right, they're not going to be able to test the logic of that, right, potentially. And there's methods for discovering hidden links and things, but there's certainly more gaps in coverage with dynamic, but there is a much, dynamic means the application is running, and it is much closer to an exploit versus static. With static analysis, the application is not running. that same web application is not deployed, you can use static analysis when you write 5 lines of code. The very first class of your web application before it's ever capable of being deployed, right? You can use static analysis early in the life cycle to examine those 5 lines of code. You can use static analysis as you develop the application. Dynamic analysis can only occur when you have meaningful deployed functionality. The application exists, it's deployed, there are endpoints for me to exercise. So typically the main difference between static and dynamic is dynamic means that the application is running, right? And in static analysis, the application is not deployed at all. It is a representation of that code that we are actually analyzing, not the exact code itself, and not any application. We're not having to go to an application server where it's deployed.
Maybe you could touch on why it's important. Why should people be doing this type of testing?
Yeah, so static analysis is uniquely positioned as it's early in the life cycle of any of the testing tools, right? So as I was mentioning before, you can start static analysis as soon as you have code, right, that can be modeled, right? That can be the very first class. You get specific code level detail. For a developer, the results are significantly more specific with static analysis than they are with dynamic analysis. Dynamic analysis is going to show you a screenshot and a URL. It is up to you to go discover what is the code behind. What class is that in? What line is that in? Right? It just has the request and the response. It has what was presented to it in the web application. With static analysis, right, you're not given a screenshot. The exploit was never actually exploited. Right? You're given what exact path this data takes in your proprietary code and exactly what line numbers to fix. And for the example of SQL injection, right? You can see the entry point where the unvalidated data comes in. You know where you need to validate that data. And then if you're sending that data to a SQL execute statement, you have specific content that tells you on line 24, you sent that data there. You shouldn't do that. You should validate that data before you send it, and you should use bind parameters in SQL to prevent SQL injection. You know exactly how to fix it. So it's very unique in that it can be used from developing the first line of code. You can use static analysis early in the life cycle to prevent more costly defects that are found later in the life cycle, right, that are significantly more difficult and more costly to fix.
Yeah, and I think that's an important point you touched on. It becomes more costly to fix the longer you put off, some of these weaknesses that are discovered.
There's also, I would also mention for developers in static analysis, one thing it's uniquely positioned is it's speaking the same language, right? There is no training required to tell a developer how to understand a SQL injection vulnerability presented to them in Java code. Came in on line 12. Here's the function. Then it was passed to this, then it was set to this. Then it was set to this value. Then this attribute was passed in. Then it was sent to an execute statement. Everything in there is a developer will understand, right? And they will understand and be able to read the concepts and be able to fix that, right? With dynamic analysis, you may be presented with an action. And then you're like, okay, let's go find the code that makes that happen. Okay, what did they do? They passed a response. Okay, that requires going and look at this class. There's a lot more investigative digging. But again, if you use static analysis early in the life cycle, it has been proven that you're going to find significantly less later in the life cycle, and there will be less for the dynamic tools to find. And those tend to be used as security gates, right? And they're the most painful for developers or application owners, because you can't find them out often, right, until the system is fairly operational. It's fine for legacy systems, not as good for new systems coming online.